We are going straight into the heart of the machine today
We really are.
because we have to talk about this,
Mm-hmm.
this major paradox that I think is confronting everyone who uses AI right now.
Oh, absolutely. Every single day.
We're sitting on top of this, revolutionary, world-changing technology. It can generate code, it can write essays, produce entire video concepts.
Mm-hmm.
But every time we try to do something creative with it, the output can be just wildly unpredictable.
Wildly is the word for it.
Yeah, sometimes the result is, transcendent, it's brilliant, and other times it's the polar opposite of what we intended.
It's that user's existential question, isn't it? In this age of generative AI, you're sitting there looking at the screen and you're thinking, is the answer wrong or am I asking the wrong question?
Yeah, right.
The capability is clearly there. You can see the potential, but the fidelity, the quality of the output, it just seems stochastic. It feels like it's entirely dependent on chance.
That's the core paradox. That's what we have to solve today. How do we get predictable, high-quality, high-fidelity results from a system that is, fundamentally based on probability?
Stochastic machine.
Exactly, a stochastic machine. How do we do that without having to revert to writing, thousands of lines of what feels like code, these super long prompts, just to get a single decent paragraph that actually matches what we were thinking?
We need that predictability, but without the algorithmic complexity.
Yes.
And this right here is exactly where the discipline of prompt engineering stops being this kind of parlor trick, and transforms into a full-blown engineering discipline.
Okay, so this is what people are calling prompt engineering 2.0.
That's the one. We're moving past just sort of describing what we want. We're now structuring how the AI thinks.
So we're talking about building actual software architectures.
Yeah.
But instead of using Python or Java or something, the building blocks are just natural language. They're prompts.
Precisely. The apps of the future, and I really believe this, the next generation of software tools, they're going to rely more and more on these sophisticated, structured prompts. They function as, think of them as dynamic protocols that program the LLM's latent space.
And for anyone who's not familiar with that term, latent space, that's basically the AI's internal map, right? This enormous multidimensional map of concepts and how they all relate to each other.
That's a great way to put it.
So when you give it a vague prompt, it's just kind of wandering aimlessly across this map.
Yep. Lost.
But when you give it a structured prompt, you're forcing it. You're making it follow a very specific, very constrained path toward exactly the idea, the conceptual node you're aiming for.
That's right. And our mission today is to show you how to draw that map. We're going to show you how to write those advanced prompts by focusing on the systematic frameworks that make up PE 2.0.
But, and this is important, we want this deep dive to actually stick with you. So we are deliberately avoiding the dry corporate examples. We're not building a website today.
Analyzing a spreadsheet.
Thank goodness. Instead, we are tackling something that's intrinsically complex, something that I think truly tests the ability of an artificial intelligence to replicate human nuance.
And what's that?
Comedy.
Ah, the hardest test of all.
Right. Specifically, culturally nuanced, language-specific humor. The thinking is, if we can master prompting for something as complicated as comedy, we can prompt for anything.
I love that. Humor is the ultimate stress test. It needs deep context. It needs linguistic twists, shared cultural knowledge. It even needs an understanding of, intentional bias to work.
So we are going to attempt to engineer a tall tale.
Okay.
A tall tale steeped in South Asian humor. One that would require, Hindi or Urdu linguistic nuances, even though we're going to be talking about it and building the constraints here in English.
Okay, so we're using this story as our test case.
We'll use the concept of this story, let's just call it Shutosha's buffalo, as our metaphorical lens. The source material we're drawing from even notes that Shutosha is a kind of reference to complex feedback loops in AI systems.
Oh, that's perfect.
Isn't it? It just connects this creative challenge directly to the engineering problem we're talking about. Our target output is a story that forces the AI to grasp deep cultural understanding. We want to force it to deviate radically from the internet's statistical average.
So what's the vision for this tall tale laid out for us? What are the constraints the AI needs to work inside of?
All right, so the story we're trying to engineer is called Shutosha and the Marvelous Buffalo, a Hindi tale.
Okay.
The setting is a rural village. Shutosha is our hero, our protagonist. He's a well-meaning guy, but hopelessly lazy. He's that classic comedic archetype.
I know the type.
And he acquires a water buffalo, Lakshmi. And this buffalo is miraculous, but not in the way you'd expect.
Okay, so not endless milk or laying golden eggs.
No. Her miracle is her perfect divine averageness.
Her what?
Her averageness. She performs exactly the middle amount of labor. She gives exactly the median amount of milk. She chews her cud at a perfectly predictable, mathematically average pace.
So she's statistically sound.
Perfectly. But utterly useless as a source of wealth or drama.
I love that irony. That is the perfect comedic conflict.
Exactly. And Shutoshi, driven by his ego, tries to monetize this marvelous average. He tries to show her off. And this leads to these increasingly hyperbolic and absurd fights with the village elder, who just keeps pointing out the objective, boring mathematical reality of the situation.
So the humor has to come from that specific clash.
Yes, the localized conflict between Shitoshi's completely exaggerated pride and the objective, boring statistical truth.
Wow, that is a highly complex target. That requires cultural archetype definition, hyperbolic storytelling, and the successful execution of this really abstract, ironic concept, statistical mediocrity.
Right.
That is miles beyond just prompting, write a funny story.
It requires structure. And, before we dive into how to build that structure, I just want to take a moment and express our gratitude to you, our listeners.
We really do appreciate you all tuning in.
We do. And I truly wish we could show you the craft of prompt engineering, which I firmly believe is the future of creativity. I wish we could do it in a beautiful, creative video.
Yeah, there's only so much you can communicate with words on something this visual.
Right. I know so many of you are visual learners, and we're working so hard to expand what we can do to include high-fidelity video concepts that are actually generated by AI.
But for now, we're constrained. We're audio only, and that constraint is, it's driving us to constantly iterate and improve our format. But this kind of deep, structured content, it takes significant resources.
So if you appreciate this kind of, anti-slop, deeply researched content, please subscribe or share this deep dive. Your support is what drives us forward. It lets us hit those milestones we need for better production tools.
We really do strive to be the most detailed, high-fidelity resource for you.
Whether you geek out on AI, deep finance, deep science, or deep spirituality. I'm Satoshi.
And I'm Satoshi.
Okay, now let's get back to taming this stochastic beast using prompt engineering 2.0.
Let's do it.
So we've set our goal, this highly nuanced, culturally specific comedy. But before we get to the Cure PE 2.0, we have to really understand the disease.
The why.
Yeah, why do we need these elaborate frameworks in the first place? Why can't we just ask the AI, write a funny story about a man and his average buffalo?
Because we have to face the algorithmic reality. And the reality is that LLMs are fundamentally stochastic machines. They are completion engines. They're built on predictive probability.
They are magnificent predictors. I mean, they're trained on nearly the entire searchable internet, but that's the key word, right? Prediction, not understanding.
Exactly. The core mechanism is, at its heart, simple. It's continuously seeking the most statistically likely next token.
Next word or...
Right, the next word or punctuation mark or even just part of a word. It's all based on the text that came right before it. So if you feed the model an unstructured prompt...
You're giving it maximum freedom.
You are. You haven't constrained the probability distribution at all.
And this is where that old digital principle comes in, right?
Yeah.
GI go. Garbage in, garbage out.
It's GI go on a massive scale. When your input is vague or unstructured or just kind of conversational, that old descriptive prompting, what we'd call PE 1.0, the output is going to reflect that low entropy.
So when the model gets that low entropy input, like write a blog post about AI.
It defaults. It defaults to the path of least resistance. It goes and retrieves the statistical average of its training data about AI blog posts.
It just flattens the probability curve.
Exactly. It gives you the safest, most neutral, most frequently occurring combination of tokens it can find. And this average, this is what we define technically as slop.
Okay, and while our tall tale is, pretty low stakes, this slop concept has some incredibly serious high-stakes implications in corporate and technical environments.
Oh, the cost of slop in a business setting is enormous. Unstructured input leads to outputs that they undermine brand voice because they're generic.
We call that synthetic filler.
Right. Or even worse, they're factually unreliable. And then you're talking about hallucinatory fabulation, where the model is literally inventing facts or making up non-existent code libraries.
I remember this. I tried to use a simple description prompt once for a new product sales email. And the synthetic filler that came back it was so embarrassing. It was full of synergy and leveraging best practices.
Oh, no.
I just had to scrap the whole thing. It was grammatically perfect, but it was profoundly meaningless.
And that's the danger. Think about the software development world. We're seeing developers accept AI-generated code. Some people are calling it vibe coding because it looks plausible. It feels right.
But it's not tested.
Not rigorously. And this trust in what is essentially slop code can lead to security vulnerabilities. There's even a term for it, slop squatting. Malicious actors register the non-existent package names that the AI hallucinated.
And they just wait.
They wait for an unwary developer to import them into their project.
So Slop isn't just bad prose. It's a structural and a financial threat because it generates this dangerous veneer of competence.
That's the perfect phrase for it, a veneer of competence.
Let's try to formally define AI slop then.
Okay. We define AI slop as low-effort, coherent, but ultimately meaningless content, whether that's text, images, or code, that possesses that veneer of competence.
It's grammatically and superficially sound.
Right, which makes it far more dangerous than traditional spam. Spam is usually incoherent or obviously malicious. Slop is just uncannily average. It creates an illusion of quality that masks its deeper failure.
And we can actually categorize these failures based on what was missing from the prompt.
Exactly, based on the prompt's deficit.
So let's start with category 1.
Category 1 is synthetic filler. This is that repetitive, overly polite, generic corporate speak we were just talking about. The excessive use of transition words like furthermore or in conclusion without adding any new substance.
And that's caused by constraint deficit.
Yes. The user just failed to specify a needed style like, say, short, punchy sentences or a tone like wry humor.
Okay, category 2, hallucinatory fabulation. This is the scary one. The plausible but false facts, the invented citations, those non-existent code libraries we mentioned, package hallucinations.
This comes from a grounding deficit. The prompt lacked either a reference text to anchor the facts in reality, or it was missing a necessary verification step, like a chain of thought instruction.
So the model just prioritizes sounding right over being right.
It prioritizes probabilistic fluidity over factual accuracy. Every time.
Okay, category 3, structural incoherence. We see this a lot in longer form stuff, right? The plot of Shutosha's Buffalo might just dissolve into randomness halfway through, or code that compiles but then fails logically.
The classic AI image with 7 fingers on a hand.
That's one.
That's an architecture deficit. The user treated a complex, multi-stage, task-like writing a coherent 3-act story as a single monolithic query.
Instead of a multi-step workflow.
Right. And the AI's attention mechanism just loses coherence over that long context window.
And finally, category 4. Emotional dissonance. This is the classic failure we see all the time. An overly cheerful response to tragic news. Or an inappropriately formal tone when the context demands casual empathy.
And that's a persona deficit. Simple as that. The prompt failed to define the required role-like act as a grieving friend, or the audience. So the model applies this generic, polite, safe filter that ends up being entirely inappropriate.
This all just boils down to the need for structural intent. We need a way to force the AI out of this statistical average.
And that's where we circle right back to the Shutosha's buffalo metaphor and this idea of linguistic entropy.
Okay.
Think about that famously ambiguous sentence, buffalo, 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 buffalo.
8 identical words in a row.
It's grammatically valid, but it's cognitively opaque. It is linguistic slop without context.
Because the word buffalo can be a proper noun, the city.
Right.
A common noun, the animal. Or a verb meaning to bully or intimidate.
Exactly. And to resolve that ambiguity, to make any sense of that sentence, the user has to provide a parse tree. We have to tell the machine which buffalo is the subject, the noun, which one is the modifier, the adjective, and which is the action, the verb.
So the role of prompt engineering 2.0 isn't just asking better questions, it's providing the syntax tree of our intent.
That's it. We are moving from being passive consumers of AI content to being active architects of the AI's cognitive path.
All right, so we're ready to start building that parse tree for Shutosha's Buffalo. PE 2.0 is about turning that vague conversational attempt into a systematic, measurable business process.
That's dynamic protocol.
Right. These frameworks are what ensure we define all the necessary variables to guide the LLM's cognition layer.
And we start with the absolute essential minimum for any kind of focused result, RTF. That's role task format.
Okay.
This structure is designed to resolve the simplest forms of the persona, architecture, and constraint deficits right out of the gate.
So the role R is the anchor. It defines the AI's perspective, its expertise. Instead of just saying write a story, we constrain it. We tell it to act as an expert South Asian tall tale writer specializing in satirical regional humor.
And that single instruction activates a very specific cluster of language and structure in the latent space. It narrows the search field dramatically.
Then the task, T. It has to be actionable and clear. So for the first phase of our story development, the task might be outline the key plot points and character descriptions for Shutosha's 3 failed attempts to profit from Lakshmi's averageness.
Super specific, I like it.
And the format, F, is how we prevent that initial structural slop. We have to specify the output structure. So for an outline, we demand a numbered list, strictly marked down formatted, including bracketed descriptions of Shutosha's emotional state at each stage.
So this RTF structure, it forms the very beginning of our post tree. It assigns a grammatical function to our high-level intent. We've told the AI who it is with the role,
What it must do with the task.
and how to deliver the result with the format. This is the absolute minimum requirement for getting focused output.
But the story of the perfectly average buffalo needs more than that. It needs logical depth. To make sure that central irony lands correctly, we need structured thinking.
Which is where we bring in the next framework.
This is where we bring in chain of thought, or CUTI.
CUTI is the mechanism that mimics human problem solving. It forces the AI to break a complex task into a step-by-step process.
And that doesn't just improve performance, right? It actually improves the reasoning.
It does because it constrains the search space sequentially. The model has to commit to one step before it can even move to the next. It can't just jump to a conclusion.
This is why CUTI prompting can improve accuracy in, say, mathematical reasoning tasks so significantly, because it's forcing the model to show its work rather than just guessing the final answer probabilistically.
And for our tall tale, CUTI is absolutely vital to ensure the humor is logically structured and culturally relevant. We need to define the steps required to execute the story's core irony.
Without it, the AI might just accidentally make the buffalo miraculous in a conventional way, and the whole joke is destroyed.
It would default to the statistical average of miraculous animal story, which involves magic, not math.
So how do we apply COTI to Shutosha's buffalo? We could use what's called zero-shot COTI by simply starting the prompt with that magic phrase. Let's think methodically.
Or let's think step by step, and then we define the required sequence of cognitive steps for it to follow.
Okay, so step 1. Establish the cultural setting, the rural village, the attire, the societal dynamics.
Step 2. Define the central hyperbole Lakshmi's perfect averageness and establish its mathematical objectivity.
Step 3. Introduce the rising action. That's Shutosha's exaggerated pride and his first attempt to monetize this.
Step 4. Detail the conflict with the village elder, and we'd need to ensure the dialogue emphasizes culturally specific proverbs about mediocrity.
Good point. And then step 5. Resolve the action with a specific ironic twist that reflects that cultural context, proving that being perfectly average is, in fact, not profitable.
By imposing this cognitive sequence, we prevent that structural incoherence that comes from an architecture deficit.
The AI can't just jump straight to a random twist.
It has to follow the logical progression of the irony we've laid out for it.
Okay, so now we have the structure and the thought process defined. Now we need consistency. We need cultural alignment.
And that's the job of the next framework, CARE. That's Context, Ask, Rules, Examples.
And this framework is designed to prevent inconsistency,
which is a primary cause of synthetic filler. This is crucial for maintaining a brand voice in business, or, in our case, maintaining cultural fidelity in a story. CARE tackles the problem of the AI forgetting or diluting the constraints over the course of a long response.
So the context C is the heavy front-loading of background detail. For our story, we'd specify. The cultural setting is rural North India, Pakistan. Audience is familiar with 1970s Bollywood comedic archetypes. The core thematic tension is hyperbole versus statistical reality.
Then the Ask A is the specific content request, a complete single draft 1,000-word story ready for voiceover narration.
And here is where we tackle that constraint deficit head-on. The rules are:
these are non-negotiable constraints on style and structure. We have to constrain the AI's linguistic choices. So, for example, tone must be wry and slightly irreverent. Avoid any modern English slang or idioms. Dialogue must be formatted for prose.
ensuring descriptive verbs and stage directions accompany the speech.
That specific rule about dialogue is so critical for moving from slop to actual prose.
It really is. If we just ask for a story, the AI defaults to that conversational script format, character name, dialogue, which looks terrible in a narrative.
So our rule has to be super detailed. We have to explicitly state, dialogue should follow novel convention. New line for each speaker, using speech marks for spoken words, and utilizing adverbs and descriptive verbs like muttered or boasted, rather than simple character names and colons.
This is the parse tree being built, component by component. You're assigning the grammatical function of descriptive prose to the dialogue tokens. You're preventing the AI from selecting the conversational API response token set.
And finally, the examples E section of CARE. This might be the most powerful tool of all for steering the latent space.
Because you show the AI what quality looks like.
Absolutely. For our tale, we might provide a short excerpt from a classic Punjabi folk story, or even a P.G. Wodehouse passage, focusing on that hyperbolic yet formal style.
To guide the AI toward the desired linguistic style and rhythm.
Exactly. Examples bypass ambiguity by providing specific, high-fidelity reference points.
Okay, now we step up to the advanced frameworks. The ones designed specifically for injecting personality and avoiding that blandness that comes from the average internet tone. Let's talk about Create.
Create is ideal for persona-driven, non-bland tasks. It uses the character and example segments to activate very specific associative clusters in the model that are related to emotion and role.
The character C is the foundation. And remember, here we're defining the storyteller's voice, not just the characters in the story.
Ah, a critical distinction.
So we command. You are a village elder who recounts local legends with excessive comedic exaggeration, hyperbole. You speak with the slightly formal yet familiar style of a traditional storyteller from rural Punjab, ensuring your language is rich with specific, localized metaphors, not generic, global cliches.
That instruction, it's so much more detailed than the one in RTF, and that's what makes the output feel authentic. It guides the AI to search the latent space for tokens associated with that very specific character cluster.
Create also has request, examples, type of output, and extras. But the adjustments, A section, specifically using negative constraints, that's where we can truly refine the output and get rid of any subtle residual slop.
Negative constraints are essential for quality control in creative tasks. If the AI is defaulting to safe generic language, you use the adjustment section to forbid it.
So to avoid that synthetic filler, we could say, do not use English idioms like as quick as a flash or as white as a sheet. Instead, focus on local metaphors, such as pale as a washed-out shroud or quick like a goat scattering feed, that are specific to that rural region.
And that right there is the difference between a generic output and a culturally resonant one. It's using constraint to push the AI toward originality.
Finally, we have to look at the gold standard for high stakes and complex scenarios, CoStar.
This is the framework you use for enterprise-level prompting. It's designed specifically to mitigate hallucinatory fabulation and irrelevance by heavily front-loading and compartmentalizing all the context.
So CoStar stands for context, objective, style, tone, audience, and response. Now, context and objective set the scene, but the real differentiators here are style, tone, and audience.
Without defining style, S, and audience A, the AI just averages its responses. It generates slop that fits no one. Style is crucial. If a corporation is analyzing data, they might specify a McKinsey-style consulting report.
And that forces the model into a structure of executive summaries and bullet points.
For us, the style must be hyperbolic, tall-tale structure, utilizing the narrative rhythm common to comedic folk stories.
And the audience, A, has to be precisely defined, especially for humor, which is entirely audience-dependent. So for the Buffalo Tale, we would specify family audiences in Mumbai, Lahore, familiar with the specific cultural and aesthetic elements of 1970s Bollywood comedic style and rural social dynamics.
And that heavy constraint forces the AI to access specific cultural and historical knowledge and actively suppress its generic templates.
It demonstrates the shift.
It does. We're not just telling the AI what to write anymore. We are providing the detailed cognitive map, the full parse tree that's required to make the output predictable and aligned with our highly nuanced intent.
It moves the outcome from probabilistic guesswork
to measurable, aligned output. And that is why Prompt Engineering 2.0 is an engineering discipline.
So one of the great benefits of contemporary LLMs is the inherent memory of the chat session. Prompting is iterative. Once we've generated that first draft of Shitosha's Buffalo using our elaborate CoStar prompt, We don't have to repeat all those constraints again.
And that ability to refine the output through conversation is absolutely essential for quality control. After that first draft, you can just use concise follow-up instructions.
Like, refine the village elder's dialogue to use more specific Urdu proverbs.
Or make the resolution 15% more ironic. The context persists, which just accelerates the refinement process.
And we can supercharge this refinement by using some key prompt extras for control. These are phrases that help us clean up mistakes or push the AI past its typical behavior, moving it out of that statistical average again.
Right, so if the model has gotten completely off track, you can instantly reset the context using a simple command. Ignore everything before this prompt.
And that gives you a clean slate without losing the memory of the session's overall parameters.
Or, let's say your initial prompt was complex and maybe a little vague. You can use a critical instruction. Ask me questions before you answer.
Which forces it to gather the necessary context. It prevents the AI from just making assumptions and generating immediate slop because of a grounding deficit.
And for analytical tasks where knowing the logic is paramount, you just use explain your thinking. It's like a non-formalized, on-demand chain of thought instruction. It lets you verify the model's logical steps before you accept the final answer.
And my favorite one, for creative tasks. If the story is still too generic despite all our constraints, you can use the ultimate challenge to push the model. Act unlike a typical AI.
That's a good one. It directs the AI toward non-obvious, non-typical approaches that actively avoid the statistical average.
Now, we have to acknowledge that some experts predict that this current mastery of prompt engineering, this complex textual input, it might be a temporary skill.
Right. As AI models get more advanced, they may be able to intuit our intent better. They might even write the prompts themselves.
So if the ability to perfect the text input diminishes in value, what's the truly valuable long-term skill set we should be focusing on?
I think it shifts. It shifts from perfecting the prompt to mastering problem formulation.
Okay, explain that distinction.
Prompt engineering, as we've discussed, focuses on crafting the optimal textual input. But problem formulation emphasizes defining the focus, the scope, and the boundaries of the problem itself.
So regardless of how sophisticated the AI input mechanism becomes,
the human ability to define what needs to be solved and why those boundaries exist, that will remain the lasting critical skill set.
That makes sense. We have to end by confronting the problem of AI slop itself, the disease we designed PE 2.0 to cure. We've shown how these frameworks combat it, but let's re-emphasize that distinction between slop and traditional spam, and why slop represents a much greater societal danger.
It really does. Traditional spam is generally malicious, it's often incoherent, and frankly, it's pretty easy to filter out these days. AI slop, on the other hand, is incredibly difficult to prevent.
Precisely because it has that dangerous veneer of competence.
It's coherent, it's grammatically sound, often structurally correct, and yet it's utterly devoid of genuine insight or the necessary constraint. That makes it incredibly difficult to spot, or even to prove that it lacks meaning.
And this content isn't ill-intentioned.
Not at all. It is merely the statistically likely outcome of the human user's failure to provide the necessary structure. It's the result of us being unable to supply the parse tree to command this incredibly intelligent machine we've built on our collective intelligence.
And the societal impact is, it's critical to understand. Slop is cheap to produce, it dilutes genuine content, it degrades brand voice for businesses.
And through hallucinatory fabulation, it can mask disinformation by making fabrication seem plausible and even verifiable.
Ultimately, the rapid, massive proliferation of slop feeds what some people are starting to call the zombie internet.
It's a closed feedback loop where bots are communicating with bots using the statistical average and gradually lowering the cognitive quality of the entire digital ecosystem.
And the only solution is disciplined intent,
which is the core of prompt engineering 2.0.
Our journey today, from the basic RTF framework all the way up to the enterprise-level CoStar, it really demonstrates that precision of output isn't magic. It's architectural design, and it's driven by the user.
So we've spent this deep dive analyzing how LLMs, when they're left unconstrained, just default to this average, meaningless content. And we've actively tried to avoid that very outcome here today by applying the highest levels of structure to our analysis.
We really want you to know that the content we create on this deep dive is built specifically to avoid slop. We work hard and iteratively to structure these conversations so that they're thought-provoking, they're detailed, and they deliver high-fidelity information.
And we insist that this quest for quality content has to be a community effort. The content we share is, in a way, open source because we derive our learning and structure from the sources that you, our listeners, share with us from all over the web.
We truly invite you to collaborate with us. If you feel our analysis, say, on the CoStar framework or our taxonomy of Slop is even slightly off base or incomplete, please share more sources in the comments.
The goal is to achieve a necessary symbiosis of artificial and natural intelligence in our pursuit of knowledge.
And we're also always looking for human collaborators, people who are committed to these anti-slop principles, who could maybe review and critique our content before we publish.
So please drop a comment if you want to help us ensure we're delivering the highest fidelity, most disciplined content possible.
Now, let's leave you with one final thought that builds on the complexity of cultural humor and the constraints required by AI.
Okay.
We use the challenge of engineering a South Asian tall tale, a story that relies on shared cultural bias and linguistic nuance, to illustrate the power of specific constraints.
And since these AI systems must be heavily constrained to avoid generating slop, and since cultural humor intrinsically relies on subjective, shared, and often localized bias to succeed,
Does generating truly high-fidelity, culturally specific AI humor require the model to adopt a form of intentional bias that's defined by the user's constraints?
yeah.
And what are the ethical implications of that specific constraint, which forces the model away from its neutral statistical average?
Wow. The ability to generate non-average output requires us to make intentional choices about what average we want to deviate from. That's a powerful question. It sits right at the intersection of engineering and culture.
Keep searching. Keep the quest on. We'll see you next time on The Deep Dive.